To understand how a modern factory works, you must look at the speed of consumption. Raw materials, labor hours, and utility inputs are continuously feeding into the facility, while finished goods are rapidly ejected out the other side. If we want to account for all this, the most intuitive method is actual costing. Mathematically, it's straightforward. You record the exact cost of materials, the exact cost of labor, and the exact overhead incurred. This graph plots actual per-unit costs over time, revealing the fatal operational flaw in that intuitive approach. Because overhead is fixed and production fluctuates, exact per-unit costs create extreme jagged peaks and valleys. Relying on this volatility and delayed invoices yields misleading data. A January item looks vastly more expensive than the same one in June. Navigating this environment requires a specialized internal reporting architecture designed specifically for decision-making, moving beyond the limitations of raw historical data. Engineering this architecture requires solving three sequential problems: the valuation of inputs, the accumulation of costs, and the dynamic control of operations. Financial accounting is a passive record of the past. Managerial cost architecture is an active tool designed to navigate the present and map the future. The first structural problem to solve is the valuation of those inputs. We have to resolve the volatility. The initial upgrade from actual costing is a method called normal costing. Look at this updated chart. Under normal costing, the system tracks actual direct materials and actual direct labor. But for overhead, we plot a smooth, pre-established budgeted rate directly through the noise of actual data. Because this rate is budgeted, a mathematical gap inevitably arises between applied overhead and actual factory overhead. Accounting rules dictate how to handle this gap. If immaterial, it is allocated directly to cost of goods sold. If material, it is prorated across cost of goods sold, work-in-process inventories, and finished goods inventories. Normal costing still relies on fluctuating actual materials and labor. For higher precision, the architecture evolves into standard costing. Standard costs are predetermined attainable unit costs. They explicitly exclude past inefficiencies and serve as objectively determined estimates that account for expected future changes in the production environment. By adopting standard costing, management stops passively recording what costs were. They actively define what costs should be, which simplifies record-keeping and sets a rigorous baseline for success. Once costs are cleanly valued, the second structural problem emerges. How exactly are those costs mathematically attached to the product? The answer depends entirely on what is being built. If the factory produces items with distinct individual characteristics, it requires job order costing. This photograph of a shipyard shows a classic job order environment. Each wooden boat is custom built within its own discrete workspace. In this setup, costs are explicitly attached to a single identifiable job. All the specific materials and labor track directly to one distinct end product. This system fails entirely in environments where similar products are continuously mass-produced. For continuous manufacturing flows, the required mathematical system is process costing. Here we see a continuous process environment, a long, unending stream of identical candy units flowing through a packaging phase. Because individual items cannot be practically tracked in this volume, process costing attaches costs to entire departments or phases of production rather than specific units. This creates a core complication. When the reporting period ends, production doesn't magically stop. There will inevitably be work in process, raw materials, and partially finished units left suspended in the machines. To account for these costs, these work-in-process units must be restated mathematically. We convert the partially completed inventory into a smaller number of fully completed virtual units, known as equivalent units of production. Establishing these equivalent units is mandatory. Without them, you cannot calculate an accurate average cost for the period using FIFO or weighted average methods. These cost accumulation systems function as rigid mathematical reflections of the factory's physical reality. Even with the right accumulation system, a hidden danger remains when applying broad overhead costs evenly across complex multi-product lines. This is peanut butter costing. It inaccurately averages resources, aggressively spreading costs evenly over products that actually use vastly different amounts of overhead. This averaging drastically distorts product costs. A simple, high-volume product ends up subsidizing the complex, machine-intensive requirements of a low-volume product. This flowchart demonstrates the structural fix, activity-based costing. Instead of a single broad spread, the pool of resource costs flows down and sorts into specific activity nodes. Activity-based costing first assigns costs to those specific activities, and then links those activity costs directly to the physical goods based on their actual usage. Resolving overhead distribution is critical, but the cost architecture must also expand its timeline beyond the factory floor through lifecycle costing. A product must be priced to cover all costs incurred over its entire lifespan. This includes costs incurred long before production begins, such as research, development, and product design, which are termed upstream costs. It also requires capturing costs incurred long after production finishes, like marketing campaigns and ongoing customer service, classified as downstream costs. Without activity-based costing resolving resource distortion and life cycle costing capturing total lifespan expenses, management operates on a dangerous illusion of profitability. With valuation, accumulation, and allocation solved, the architecture is ready for its final activating pillar, dynamic operational control. At the start of a period, management creates a static budget. This is their best initial projection of the resource consumption and output levels they expect to achieve. This chart shows the problem with that projection. If we compare a blue static budget against a taller gray actual output bar, the absolute costs will naturally mismatch. Evaluating performance against a static budget fails entirely if the factory produces more or fewer units than expected. Accurate performance evaluation requires a supplemental tool known as flexible budgeting. A flexible budget recalculates the expected quantities and costs strictly based on the achieved level of production. We scale the expected budget up or down to match the actual physical output. By comparing actual results against this new flexible budget, the noise of volume changes is stripped away, and true operational inefficiencies are finally isolated. These isolated differences between our actual costs and our flexed standard costs are defined as variances. Isolating these variances facilitates the primary objective of this system, management by exception. Variance analysis enables leadership to ignore the expected daily noise of the factory. Instead, they can focus their attention and resources entirely on significant deviations from the standard, whether favorable or unfavorable. By smoothing valuation with standards, matching physical flow with strict accumulation, and flexing the budget to isolate true variances, raw manufacturing data is transformed into a precision instrument for executive control.